Hello everyone, welcome to Domain 10 Application Security. Application security is also evolving at a rapid pace as the practice of application development continues to progress and embrace new processes, patterns, and technologies. Cloud computing is one of the biggest drivers of these advancements and bring with it the urgent and imperative needs to ensure that progress is stable, scalable, and secure. So let's deep dive. Okay, Domain 10 application security is the 10th domain out of the 12 domains, and the learning objective for this one is more towards implementing a secure development process for creating secure application. Recognize the critical role of architect in ensuring the security of cloud applications. Automate the integration of security throughout the secure software development lifecycle using DevSecOps. Okay, secure development lifecycle. So any secure application will start with a secure development process. As you understand, if you have a team of developers, their primary job is to build a functionality, but which is not sufficient. You need to have a development and implementation done, which is actually more secure. So when we say secure means from the initial design phase to ongoing maintenance, the security of the cloud-based application requires careful consideration and proactive measures. Hence, there are different stages which are defined in SSDLC, which is Secure Software Development Lifecycle. So the first phase is secure design and architecture that actually apply during the design of the product itself. When you are designing, gathering the requirement, that's where you actually consider or apply or keep secure design in mind. Okay. Secure coding is identify the weakness which kind of cannot be identified using manual human intervention or the reviews. So code comparison, the way you are writing the codes, you have variables which were never used. So all these. Then you have continuous build, integration, and testing. That means you are implementing security testing is or part of the process itself. When you are developing or you're building, writing the code, you're doing the integration or performing different levels of integration. So this has to be as part of the SSDLC process. Okay. Then continuous delivery and deployment. This is the pre-deployment stage where you ensure the application which you have created or designed is secure and on deployed on a secure infrastructure itself. Okay. Then definitely, as we always say, is continuous improvement. So whenever you have an application which is running, then you need to have a runtime defense and monitoring, which is part of the continuous improvement, which identifies inefficiencies, vulnerabilities, and weakness that can enable or cause an incident. So all in all, there are five phases. I think this is a very good slide. Keep note of this and the stages as well. Okay, threat modeling. So it's a structured process that is used to perform risk management, that is to identify, assess, and address potential security threats to an organizational assets. When we say organization asset, it could be your website which is hosted, and that is the way or the front face for your organization. So that also counts as an asset. Okay, this actually understands how the system architecture is. You identify what is your security objective. You want to have a multi-factor, single factor, or multi-factor, two-factor authentication. You identify what could be the potential threats, insider, outsiders, how what is the data flow. So all in all, this is a very structured process. Stride, keep note of that. Stride is an example of threat modeling. If I'm not wrong, Stride is from Microsoft, but I need to revalidate it. But yes, moving to the framework itself. So it actually has got six categories and is a spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. We go one by one. Spoofing. So it's like pretending to be someone else, such as a user or a system. That means you want to gain an unauthorized access and you behave as a legit actor and then you want to steal some data. Okay. Tampering, you want to alter, you want to modify the data which is in transit on the storage, or you want to compromise the data integrity. You change the values. Okay. Repudiation is when a party denies that they have not performed it. Okay. So this is undermines the system ability to attribute actions to the correct sources. That means if X person has performed a task or a system has performed a task and then they deny. Okay. So we need to have repudiation in place. Information disclosure, unauthorized access to confidential information. Usually, information disclosure is tackled by encryption. That's one of the way of handling it. So you ensure the communication is all secured, and then you don't have any exploits or a vulnerability that can access the sensitive data. Denial of service is always, or more or less, is actually towards the availability of the system. Okay, that means you try to uh, overwhelm the system with a lot of requests so that it becomes unavailable. Elevation of privilege, as it says, moving lateral and horizontal. That means from a normal user become a system administrator, or you actually try to you are a user A and then you try to mimic it as a user B. So that's the way you actually elevate the privileges from one lower permission to a higher permission or more permission. So Stride, do make note of that. I'm still not sure it's part of Microsoft, but again, never mind. You have to understand that Stride is the framework that is used for threat modeling. Okay, testing pre-deployment. So actually, teams can actually save significant time and resources if they perform integrated testing early in the development process. And how it can be done. So there are a few ways when you perform your testing. It's called SAST, SCA, and also you can even use your existing IDE, developers IDE, to actually perform these checks. So what are these? Let's go and discuss about it. So automated security code review is more of a static application, static security testing, SAST, which actually, when you're writing the code, when you're creating the code, then at the writing of the code itself, you can perform a checks. That means, let's say you created a variable and that variable was never used. Maybe you created a function, that function was never used. You never called in the exceptions properly. So all those things actually come in handy when you are doing the development part. And that's what they call as shift left. That means you engage or implement security at the early stages. Okay, and how it will help you. So actually, it will look for the logical errors, examine specific implementation, check style and the guidelines, how you're writing, or any kind of security flaws. Okay, it also verifies whether you are using any hard-coded credential, keys, tokens, secrets, which are not allowed. You don't should not be using it. You should be using system variable. Okay, so and this is the analysis. Then comes in the software composition analysis (SCA). It's more towards when you are evolving or performing a checks that what all binaries or system components are used to set up the environment, to set up the software itself. That's where you perform a software composition analysis. Even software composition analysis helps you to create a SBOM, which is called software bill of material, which is required as certain standards. That means you need to have a SBOM to understand what are the components being used, whether they are vulnerable, non-vulnerable, and all that. Okay, and an important thing is ISC, infrastructure as a code. So when you actually write those codes, you should be performing software composition analysis and static application testing to check whether you have any secrets, the images are signed or images don't have any vulnerabilities, and then you are not violating any kind of policy while writing infrastructure as a code. So these are the key things which you use for a pre-deployment testing. Okay, so post-deployment testing, it actually checks and verifies your security and functionality after the code has been deployed in the test environment. So what you perform is a dynamic application security testing called as DAST. Then you also have interactive application security testing, IAST. Okay, and then you have pen testing and bug bounty programs. So let's go one by one. DAST stands for Dynamic Application Security Testing, where actually you perform some kind of simulation whether the application is vulnerable. You try to do fuzzy testings, you perform business or logical errors, and that's where you actually understand what or how the application is responding to it. Okay, it's more of a black box testing. You don't have much of the information, and that's the way you perform it. Interactive application security testing actually is considered as a combination of SAST and DAST. So SAST, when you know you are writing the code, you have code assessment, you check the codes, whether you have variables and all that. Simultaneously, you're performing a dynamic application security testing, which actually achieves both the function. So it actually happens at the same time when you're executing the code, you validate or review the code. So it happens hand in hand. Okay. Penetration testing is something you will understand from outside in. That means you have an application which has been hosted and then you want to see if it is being exploited or it can be exploited. You have resiliency for the security. That means they can withstand with the attacks. It could be a automated, it could be a manual exercise, but more or less this could be a white box and a black box testing. Usually it's a gray box testing is the best way, where you feed in some basic information to the pen tester, you do a walkthrough with them of the application, but you don't let them Let them have everything, have all the information. So the gray box testing is something I would prefer, I would recommend, because I've seen that it goes worth. It actually saves time for both the parties, the one who is performing the test, and then the owner of the application, or the product or the asset. Okay, and then comes in bug bounty. Bug bounty is more of a reward system, monetary reward system, wherein actually you are asking ethical hackers across the community to come in and validate. Okay, because pen testing, it all depends how and what is the style of a pen tester. How does he see business logic? Does he see vulnerability? Does he see his code? So depending upon their capability. But when you perform a bug bounty, you are expanding the assessment, or you want a community to actually perform a security assessment for your system. So I would say all of them have their own pros and cons, because penetration testing, what I've heard or seen is, you perform annual pen testing. That's one key thing, and then you can have it at different phases as well. Bug bounty is actually a very huge exercise. You need people who actually can engage, and then you have to have rules of engagement, then you have set up the environment, uh, but then yeah, they have their pros and cons. But yes, all in all, these are the four things for a post deployment testing. So what is an impact of an architecture, or how an architecture actually uh, impacts the overall security of the cloud application? I will also introduce a word called SRE, Site Reliability Engineer. We'll go about it later. Okay. So start with, as we understand, in a traditional software environment where we have infrastructure also, but in a cloud environment, everything is a software. It's a logical construct. It's not a physical construct in all means. So it's a logical construct. Could be a network firewall, or a load balancers. Everything is a software base. Okay, and they are tightly integrated within the application. Let's say you have a load balancer, an application load balancer, a WAF. Okay, so as an architect, they have to see how the infrastructure and application integrate. How will be the traffic flow? How will be the identity? What are the databases? How they're distributed? Whether they are managed by the company itself, self-hosting, or it is actually something which is, comes as a service like AWS RDS. And then how you're going to do the spin up and spin down, or vertical uh, expansion, and horizontal expansion. Okay, then comes in how you're managing the credentials. Application also have a lot of credentials. They could be have a token or API key, or certificates. How you're managing them? Are they exposed? Are they kept safely? Are they rotated? Creation, deletion, is it happening on a in a right way? If there's any misconfiguration, it can lead to a security incident. Okay, then, as we said, everything is a software. Then you have ISC, infrastructure as a code. Then you have a pipeline. How are the pipeline engaged? Who's writing the pipeline? Who's approving the pipeline? So, to give an example, let's say there is a development team who is writing the pipeline, but that pipeline is connected to your AWS account, and that's the point wherein you write the application code, or and then you actually execute in the AWS itself. Okay. Then comes the immutable infrastructure. This is very key. Always remember this. What we prefer to do is, whenever we create a new instance, we try to keep it immutable. What it means is, in case you have to rewrite or you have to change any functionality, you will rewrite the code, you will build a new instance. You will not be using an old instance, modify that. You will create a new instance, and then you will replace it entirely. So that's very important. Okay, so there's a discipline called site reliability engineer. It plays a crucial role, and their role is more towards to ensure that there's a reliability across a large scale cloud systems. They actually take a uh, their role is more of a middleman, where they understand what is the engineering perspective, how the operation works, what are the infrastructure and the application. So they actually try to be kind of someone who's coordinating, managing, and designing and understanding. That's the role. So quite important. An architect plays a very important role when you're uh, creating an application or doing a migration in a cloud environment. Okay, moving to identity and access management and application security. So IAM will play a key role in enhancing application security, and even IAM is actually is one of the key pillar of any of your implementation. Okay, so actually, what it manages your identity and regulate access within the organization, right? So there's a term called secrets manager. So secret management is actually what are secrets? Secrets are actually any digital authentication credentials, could be your passwords, keys, tokens. So all these are actually used by application and infrastructure as well, and they are used to communicate across different services, right? And then in the secrets management is a practice where you actually securely handle these credentials. That means you are keeping them in a way that there is a RBAC role-based access control. Then you are performing a control or sorry creation, rotation, addition, deletion, modification, and all those things as part of the exercise. So you're trying to perform this in order to have, avoid any kind of unauthorized access or any kind of a risk database, because once you have these secrets uh, available to anyone, they can be misused. Again, uh, so even the cloud providers, they have different alternatives. Some of the uh, cloud providers, they actually give you a secrets management system where you can actually create your key value parameters, and then you can use it as a system variable, then you can call it out, and then they actually call in the application and all that. Okay, similarly, uh, the key thing is there could be a third party service, okay, within a multi cloud environment or in on-prem deployments where you actually can store your secrets and you can extract it and then use it. So this is what a secrets management is. Okay, DevOps and DevSecOps. So DevOps, as the word is Dev plus Ops. Okay, so Dev is development, which is the software development, and Ops is the IT operation. And I think most of us knows that that has been always a debate that which one is important, and then whatever the development team uh, provides, and then when it goes to operation, there's always a mismatch. Okay, and in order to speed up, what we are expecting is both the development team and the operation team have to work hand in hand to actually make it a success. Okay, it more focuses on a collaboration and automation. So I will come with an angle from DevOps as a automation piece of the story. Okay, that means you have something as a plan, create, verify, then you package and release it and configure it, and then keep monitoring it. So if you see the diagram below, you have ops, which is performing a configuration and monitoring, while development is actually doing the plan, create, verify, and package. But if you see the release part, so the release part is a very common thing which both the parties have to perform. So that means when dev is releasing something, operation should be able to understand it, what are the prerequisites and all that. Now, DevSecOps is nothing but an extension of DevOps. And what we have introduced is the word security. So security is embedded. And then that's what we were sharing about shift left. That means the security is been added at the very early phase when you're performing your development. And while it goes to the testing phase, you already have validated that the logics, the business logics are correct. Then you have the configuration, the vulnerabilities, the software compositions. They all are, verified before they are packaged and deployed or so what we are trying to say here is um, that's the DevSecOps you can refer to as secured software development lifecycle. We have been using SDLC, but secure and DevSecOps somehow uh, interchangeable. You can actually use that. Okay. So now the important concept is DevOps and DevSecOps is an automated deployment pipeline. As I mentioned that we are always looking at from an automation perspective. That means whatever I create, I should be able to execute and then release it on time and or in time. Okay, and on top of that, we are also performing security checks, performing a scan to check the business logic, or could be a software composition and all that. Okay, then again, this whole thing is used via CI/CD, continuous integration and continuous delivery. There is a slide about both of them in the next one, but continuous integration is talking about merging of the codes. Continuous delivery is about releasing and putting it to a testing environment. Okay, so let's move on to the next slide. It will talk about CI/CD more in more detail. Okay, as I mentioned, CI/CD pipelines and shift left. So let's understand what is shift left. So it's a phrase which is used to indicate security. That means we are moving security in the early phases in SSDLC and ensure that secure by design, secure by default products are created. Okay, actually shift left actually drives proactive security so that you have security at the first place or the early stages rather than bolt on security at the later phases, which can be causing issue with the efficiency and other things, right? So continuous integration is merging the codes changes into a shared repository. Assuming that you have a group of developers, they all are performing an activity or they are creating different functions. And what they can do is they can merge all of them together. So that becomes a continuous integration. Now, continuous deployment comes in when you're deploying these codes or you're pushing the codes into testing or staging environment. Okay. So these are the two things. And when we are talking about continuous integration, we are somehow referring to the phase of SAST, static application security testing. But when we are talking about continuous deployment, we are talking about dynamic application security testing. Okay, so the slide you see down below will give you more details. What is the server configuration? So server configuration is, again, you do it with the IAC. You actually pull an image from the code or an image. Then you have a source code. Then you version them. The repository is version. Anytime you modify or you create a new version, you actually use it, like an example for a immutable code, wherein actually you recreate the code, but then you keep versioning it. Okay, and then when you do a continuous integration, this is where you perform your SAST, software composition analysis, vulnerability assessment, and embed security, or that requires embedded security tools. Okay, for this. Then you have a master image. Once you do, it could be a manual or automated acceptance. Once you accept it and then you deploy it, and when you deploy it, this is where you perform the next level, which is the DAST. So kind of important slide. I think should make note of that. I will just also mark it important. Okay, to the last slide. So whenever you have done your DevOps or DevSecOps, actually when you do the implementation of all these applications, always have a discussion with your infra team and understand how does a WAF and API gateway impact or how they can enhance the security functions. Okay. So whenever we talk about web application firewalls, the WAF is actually towards the HTTP traffic against known attacks. Could be a SQL injection attack or could be a directory transversal attack or similarly of those kinds. Okay, but when we are talking about an API gateway, which is address specific API security, which includes authentication, authorization, rate limiting, request response transformations. Okay, very important. So understand the difference between two. Then there are four common deployment methods or scenarios, I would say. More or less, I have seen that you always go for the second one, which is cloud provider services. But let's run through all of them. Agent deployment. So what you do is you actually have a virtual machine as a web server, and then you are installing a WAF agent on top of that as an operating system. Very small scale implementation. You don't have DDoS mitigation capabilities, so it's very minimal, very basic kind of arrangement or a setup. When then comes the cloud service provider, where actually the cloud service provider provides you WAF and a DDoS protection, and then they are intact with the load balancer. If you see the slides down below, you will see they have implemented a WAF of API gateway, and that is actually connected to your kind of Lambda functions. Okay, and the client are accessing the WAF. That is the first point. Then you have, if you have an attacker bot, it can actually block it. So this is most of the common implementation I have seen so far. You can also have a third-party marketplace service where there is a wide variety of WAF available. I can name a few to you. Is like a F5 WAF. You have Imperva as a WAF as well. Then there are quite a lot in the market. Even AWS WAF is kind of very reliable. They have actually come up with a lot of changes recently, so it's very useful. Okay. Then you can also use WAF and DDoS as a service. What you're doing is actually you are redirecting your traffic. So whatever the consumer traffic comes in, it first go to WAF, or and then from there it is examined. If everything goes fine, then it is routed to the cloud provider environment, and then ultimately landing to your zone or landing zone. Okay. So this application security, my personal view, is very important topic, and my view is when you're done with your studies, do spend an additional 10-15 minutes, go through application security, maybe visit this presentation a few more times, and get the keywords like CI/CD, DevSecOps, DevOps, what is a shift left, what is the role of a WAF and API gateway. Okay. Thanks a lot. I think two more domains left, 11 and 12. And I think after that, we will conclude this series. Thank you. Bye bye. Okay. I want to thank you again. So, like and subscribe the channel, and I will be adding more videos soon. Thanks a lot.